Well, how are you doing? Okay, I'm going to try and make this video as quick as possible because I don't want to spend too long on it. You might hear a bit of background noise. My housemate is up and I have some cats moving around here as well. Okay, this video is going to be about how satellite navigation cannot work on a globe. Okay, it's not about how it does work, right, over a flat plane. That's a different video. I have detailed that in a presentation I did on this subject sometime last year and many years ago as well. I somewhat detailed it. But this is more about how it doesn't work and how it can't work on a globe because of what the receiver must do, right? So I'm going to, rather than going through the whole presentation I did or parts of the whole presentation I did last year, I'm just going to focus on this part because this is equally as important as how the satellite navigation or GPS, let's call it, actually does work, right? Not claiming there is things flying around in the sky or there isn't. It doesn't matter. That doesn't matter. Where the signal is coming from doesn't matter to me. It's about how it's claimed to work, and I'm going to show how it can't work on a globe Earth. Okay, pay attention to this because we'll be coming back to this at the end. First of all, I'm just going to show some slides. So, right, this is the subsatellite point here, right? Here is an angle to the satellite, which is here, from one position on what would be they're trying to claim is a globe Earth, and on a second position, which what they're trying to claim is a globe Earth, right? So, subsatellite point. What you'll notice is you have straight line up, straight line down, and then a curve in between, right? Now already you can see the problem, right? Now they have this other line going to the center of their globe and another line coming out to here because they think that somehow solves it. It doesn't solve it because they don't understand there's a major problem within what they're trying to show, right? So they're trying to create two right angle triangles to solve how they can find a subpoint on the surface of the globe, but it won't work because no matter what way they work it, even if you take a straight line across from here straight over to here, that straight line will not match the distance between here and here, and that's where the receiver will be. This is where the subsatellite point will be. What's important to remember for this video is I'm detailing what would happen, right, from a cold start with a receiver. So if I'm using my receiver in the Netherlands and I turn it off and I turn it back on again in Texas, right, the receiver doesn't know where it is. It has to find where it is, which means it has to connect to 4 or more sources, right? Let's call them satellites because that's what they call them here for the globe, right? Whatever they are. Doesn't matter whether they're, because I've shown in the past when I showed how it actually works, that the source of the signal doesn't matter where it comes from, whether it comes from an airplane, a ship, a ground station, a balloon. It doesn't matter where it comes from, right? So flying in the sky means nothing. The point is that how it's claimed to work and how it actually works. But I'm going to show here how if you start from a cold start position with a receiver, how it can't work on a globe, right? So if you take a straight line across to this dotted line, right, that would be 2 right angle triangles, right? Here and here. And using their radius, the unmeasured radius, the one that they can't measure, it doesn't exist. Using that one, right, using that, you could work out mathematically, right, that the subpoint is somewhere on this line, right? Great, no worries. How do you work out this, right, distance here? The arc distance, how do you work that out? Because you need that to calculate any of the rest of it. That's important because you need to know where the subpoint is. The receiver needs to know its distance from the subpoint. It doesn't know that. That's the problem. It doesn't know its distance from the subpoint. Move on to the next, 1 second, right? Here is another one. Here is the receiver. Here is, I'm going to make it bigger. Here is the subpoint. Once again, trying to use 2 right angle triangles. But see this dotted line here, the one that wasn't in the last one there, well, it's hard to see it here, sorry, excuse me. this one. There wasn't this dotted line, right? But in the next one, there is the dotted line. Because what this actually is their tangent, right? They're trying to create two right angle triangles here, but this line is the tangent that they need to use. They need to claim to be using, right? Because they can need to claim they're on a globe, but they can't use the surface of a globe for their angle. They need to use a tangent, right? And this is where they start to fall apart. So they're trying to make it look like they're using two right-angled triangles here, and that somehow gives them a subpoint on the globe. But it doesn't, because the receiver, right, it receives the azimuth, which is the compass bearing, right, and the elevation of the claimed satellite, right? That's what it receives. That's flat. That's what's known as the horizontal coordinate system. It uses a horizontal plane. That's what the receiver uses, right? And what they're trying to do is put a tangent on the surface, touching the globe at one point, and making two right-angled triangles out of it, and say that that's all the receiver needs to find its distance to this point, right? That's all it needs just to get started, and it can use then the angles here and the angles here and all the rest of it to find its distance to the subpoint, right? Because the receiver receives the azimuth, and which is the compass bearing, and the elevation of the satellite. It also receives the time that the signal was sent, and it receives the coordinates of the subpoint. Because what the receiver needs to find, remember, is it's a cold start. It needs to find its own coordinates. It doesn't know where it is, and it's trying to use 4 or more claimed satellites to find this, right? So how can it find its distance along this arc length to the subpoint, right? It has the coordinates, but it doesn't know where it is. So the coordinates could be somewhere in anywhere. Could be in this coordinate, could be in Florida, but the receiver doesn't know that it's in Texas, right? It knows from the compass and that it's not out at sea, but it knows not what's up. But that's all it knows. It doesn't know where it actually is itself. And even if it does know it's probably in Texas, it doesn't know where in Texas. Do you know what I mean? It doesn't know this because it has to find the distance. It has to find out its distance, right, which is according to a globe, an arc length between it and the subpoint. It doesn't have that. I'm just going to move on just to show. Here we are again. Earth station, right? This is a tangent, right? Two different satellites. This is, see this yellow here, right? Dotted line, and this yellow dotted line. That's the actual angles that the receiver has. Now, they'll have them along with the compass bearings. But this is the subpoint of this satellite, right? So how is it going to find, right, with using this tangent here, how is it going to find this point? It can't, because if it has to use this tangent here, then the subpoint of the satellite has to be directly below it, because that's how an elevation angle works, right? The subpoint, just like the GP point of a celestial body in celestial navigation, is always directly below. The subpoint is always directly below the satellite. So how can it find its distance, or find how far away it is, the receiver is, from the subpoint of the satellite, right, on a globe, if all it has is a tangent and an angle off of that tangent? There's the angle here, right? It can't, because the only thing it can work out distance is from this point out to right underneath what will be the satellite here. But what good is that to you on a globe? No good. That's not helping you. It's not going to show you. You have to remember this: the receiver has basically no information, as in no information as to where it is, right? There's a lot of misunderstandings about what it does. Like, the satellites tell it, but no, they don't. The satellites just send out information. The receiver just receives it, right? I'm calling them satellites for the sake of this. The senders, the signal senders send out the signals and the information. The receiver just receives it. That's it. The receiver has to do all the work itself. It doesn't get told by the satellites where it is. Only bozos believe that. So if you believe that, well, I'm sorry for you. Once again, right, tangent, right, subpoint here. How is it going to work out the subpoint there? From this tangent, the subpoint has to be here, underneath that, because it can only use a right angle triangle to figure it out. This is its angle here, this angle here. That's all it has. So it has to pre-assume that with this angle and 90 degrees underneath the satellite, and even at that, it's going to be difficult to do, right? But it has an azimuth and an elevation. So it has this angle and it has a 90 degrees, right? And if it pre-assumes a distance to the satellite, it can then have one side length. Otherwise, it'll just have, if it doesn't have anything like that, it'll just have this angle and a 90 degrees. And it can work out the third angle, but who cares? That's not going to give you a side length. It needs to know the length between it and the subpoint. But it can never find the distance between it and the subpoint using a tangent. But there's another glaring problem that I'll bring out at the end, that is so glaring and so obvious, but it absolutely destroys the globe because it makes it impossible for them to do what they need to do, right? Because really what they need to do is be able to use trigonometry, but it would need to know, right? It would need to know a side length, right? It would need to know the height of the satellite above this subpoint, but then it would need that angle there would have to match it. So this angle here would have to match this here, right? How is it going to match that there? Because then the satellite would have to be over here above this point. Satellite would have to be up where the S is, or just above the S. It can't be over here. Do you understand what I mean? This can't be done. So from a trigonometry point of view, even if they got all three angles off of it using a tangent plane, remember, they're not using this, they still don't have a side length. It needs to know its distance between it and the subpoint. Now I show, as I said in my presentation, and I will probably make another video on the subject, or at least do the presentation again, where I show how a receiver actually finds its position, right? But here I'm just showing how the globe tries to say it happens for them, but how it can't work, and how GPS and all this navigation with satellites and whatever they want to claim can't work on a globe, simply because of what they must claim, right? It shows that it can't work. They need to know the arc length. They have no way to find that out. So we'll move on again. Here it is, right? Satellite, sub-satellite, point, satellite, right? Right angle triangle, elevation angle. So there's the azimuth from north, right? And there's the elevation, right? Right angle triangle. For all those people out there who think that elevation angles aren't right angle triangles, there you go, right? That's just, there you go. Even within your own paradigm, they're claiming it. But either way, this is what the satellite this is what the receiver has, right? With the information it gets, two of the main pieces of information it gets is the compass bearing, right, from north, and it gets the elevation, right? That's what it gets, right? As you can see, the sub-satellite point has to be directly underneath the satellite. Otherwise, it can't even get the three angles, right? And at this, the three angles aren't going to give it, all three angles of a right angle triangle won't give you a side length of it. Because that won't tell you what length any of the sides are. You need the sides. See Adam Meakin. This is a look angle calculation, right? This is like azimuth, compass bearing, right? And two objects in the sky, which is elevation. This is what they're using, right? An elevation angle, a look angle, right? More or less same exact thing, right? Using the horizontal coordinate system, and here they're using obviously the latitude and longitude, right? But which you're going to have to use for compass bearing anyway. But the point is that this is what they're using, right? Now, only reason I know there's not a very good, it's not very clear, but I just wanted to use it because it was showing compass bearing and stuff on it, right? Here are we again, azimuth angle, right? Satellite. The third line will be up to the satellite, right? Elevation angle. Now that doesn't mean it's going to that with just that right angle triangle that you will be able to find the subpoint, that the receiver will be able to find the subpoint. It won't, but it definitely won't be able to find it if this dotted line here is a tangent. It will never find the subpoint and its distance to the subpoint. It'll just have four coordinates of four subpoints and a load of information that doesn't help it do anything. That's what will happen there. Next one, here we go again. This is not good quality, but I wanted to show because it says horizontal plane, antenna, horizontal plane, elevation angle, satellite. Right, that would mean that sub point has to be here, directly below it, because sub point is always directly below, right? Just like the GP point is directly below a celestial body. Next one, here we are again. There is the line. There is the angle. So if you extend this line out here, then the sub point of the satellite is actually right around just above the eye here of the sub-satellite world, right? That's where it actually is. So what's happening here? How does the receiver find out, right, on a globe, how does the receiver here find out the length of this arc to the coordinates of the, because if it could find out the length of this arc and the three other arcs, it can then find out its own position, right? Because it has the coordinates of this point and the other 3 points. That's like 4 coordinates, at least 4, right? That's what they say. But how can it find this? Like, if you're a baller, you're going, it just uses this angle here. Because you're a bozo. You're not thinking, right? Because ballers don't be thinking. They just pre-assume and beg the question and completely miss reality all the time. Because they can't use this angle. Can't use this, can't use any of this because it doesn't have the arc to know what this angle has to be, right? You have to be able to measure the arc angle. Can't do that because it doesn't know what length the arc is. It only has this angle here and some other basic information. So if you're a baller, I'm sorry for you, but this is going to be a hurtful video. Here we are again. A dotted line, which is your tangent, right? Sub-satellite point here. Here's the satellite. No, sub-satellite point is here. That's where the real sub-satellite point would be, right? But even at that, you're going to have a difficulty finding out what the length of those sides are. But at least you can get something. You're getting nothing here. You have one angle here. Using a globe here, you have one angle. Using a flat plane, you will get to 3 angles. You get 3 angles. Now, whether it'll give you length of sides, that's another thing. But you will get 3 angles. So a flat plane will give you 3 angles. A globe will give you 1 off a tangent. And that's the end. You go, if not more. The receiver has nothing more. A load of useless information because it can't find its own position based off of the information it's getting based off of the coordinates of the 4 sub-satellite points. Because not only will it have to use a flat plane, because it has to use right angle triangles, right? Not only will it have to do that, but it will also have a difficulty finding the distance even over a flat plane. Because you have to remember, it doesn't know the distance to the sub-satellite point. And if all it has to use is right angle triangles, it's not going to find it. Because it can't know this part, because it would need to know this part to know this part. And it only has an angle off of a tangent, right? But there's other problems, and it's going to make this is going to make this video hurtful. Very hurtful for the ballers. Very, very hurtful. So here we have again, right, your tangent plane. Where does this place the sub-satellite point? Places it here, right, over here. It won't be here, it'll be over here. The receiver will not know what distance this arc is. It can't know the distance of the arc. It doesn't have the information that helps us to find the distance of the arc because it needs the distance of the arc to know this angle. It can't know this angle because it doesn't have the distance of the arc. And it can't know that because all it has is an angle off of a tangent, right? So it's no good to it. Here we are again. Here we have serrated line, right? And it's shown a sub-satellite point. How is that sub-satellite point? How is that the sub-satellite point? Technically, the sub-satellite point would be out here. That's where it would be. It wouldn't be here. It can't be. That's not a right angle triangle here, right? And even if they did use this, it's still not going to give that length because this dotted line here is not going to be as long as this arc. So this tangent, straight tangent, won't be as long as that arc. So it's still not going to, it still won't help the receiver find its position. Still won't help the receiver find its position. That's still not going to work. Next, right, here we are again from a different angle. So this angle here is all it has. This is the receiver, let's just say, this is the angle it has. It doesn't know this angle, because to know this angle, it would need to have this arc length. But if it was using that arc length as a straight line, then this angle would be different. And so would this one. This is the problem. It can't work because this angle here is based off of extra information that the receiver doesn't have and can't get. So technically, this line stretched out here would place the GP point of the satellite here, the sub point of the satellite here, based off of this angle, right? I'm going to show all this at the end. Anyway, how none of it, just going to show, just to cap it off, how it can't do it. Same nonsense again. Here's your tangent line here, and this is where the sub point would be. It won't be here, it'll be here. The receiver can't work out this arc. It can't work out the arc. It's completely lost, right? The coordinates of the arc is not going to help it. I can give me the coordinates of anywhere. That doesn't mean I'm not going to, after spinning me around and, drop me off in somewhere I don't know where I am. Give me 4 coordinates. I won't know where I am based off those coordinates. You can give me angles and all kinds of other nonsense, and I'm still not going to be able to work out where I am. I need more information, right? I can't do it, and neither can a receiver, because it's just impossible off of the information they're saying the receiver gets, right? Here we are, solar elevation, collective elevation, satellite elevation. As you can see, right angle triangles, that's what it uses. Azimuth, right, satellite azimuth, right, solar azimuth, right, it's using azimuth, right, that's what it's using, azimuth. And elevation, that's horizontal, that's what's known as the horizontal coordinate system, right? Illumination elevation angle, vertical angle measured from the horizontal plane up to the sun. When the sun is directly overhead, the illumination elevation angle will be 90 degrees. This is separate from collection elevation angle, figure 6. Collection elevation angle, a vertical angle measured from the horizontal plane up to the line of sight of the sensor. When the sensor is directly overhead, the collection elevation angle will be 90. This is separate from illumination elevation angle. What they're saying is that if the sun is directly overhead, or the sensor of this same satellite is directly overhead, then your angle to it is 90 degrees straight above your head, basically. Right? Here is the problem. Here you have, right, 2 angles to the same, from 2 different points to the same satellite, right? This is claimed to be horizontal, and this is claimed to be horizontal. Now, none of them are horizontal, right? None of them are horizontal. In reality, right, to make this work with this distance of arc between them, you must straighten out the arc, right? And this is the part we're coming to soon. And the zeniths cannot diverge for this to work. To even get your angles correct, the zeniths cannot diverge. So even if these 2 receivers here were working in tandem, they'd have to, right, have parallel zeniths for this to work, right? So they can find out, and that would then change the angle here, because once they straighten out this arc, that's going to change this angle and it'll lengthen out, make the length of this and this hypotenuse longer. But what it will do is, if they can work in tandem, you'd have to have 2 of them. So this is not just one starting from a cold start. This would have to be 2, right, working somehow in tandem. And they can figure out that if the satellite was halfway between both of them, or if they figure it off, if they were working in tandem, but they both had different, right, my angle is this, your angle is that. That means that this satellite sub point must be exactly here along this horizontal plane, right? And then they could maybe use the coordinates of that, maybe. But that still really does that tell them? Does it tell this receiver the distance to it, or this receiver the distance to it? Does it do that? And that's this. We're going into a position. We're going into a situation where there's more than one receiver working in tandem with each other. We're not talking about one receiver with a person with a completely cold start in Texas after being turned off in the Netherlands a week beforehand. Do you know what I mean? This is a hypothetical. You know what I mean? So and even at that, how are these receivers going to know the length of the adjacents, which has to be on a horizontal plane? It can. The least they'd have to do is not have parallel zeniths. The same for this. They'd have to or not have divergent zeniths. The zeniths would have to be parallel with the zenith from the sub point to the satellite for them to have any hope of finding their position. Same here, right? Azimuth, right? Here we are, right angle triangle again, right? True north, not magnetic north from compass, right? Well, that's a bit tricky, but they still have to use compass north. I won't go into all that now. But the point is that they're using a right angle triangle, and each receiver has a compass in it. So this doesn't make any sense because each receiver uses a compass. So it has to use right, compass north, magnetic north, the only real north, magnetic north. But that's for a different video. Another thing I can absolutely prove. Here we are again, right? Elevation angle. Elevation angle is the angle measured perpendicular upward to the horizontal plane in the vertical plane to the line of sight to the satellite. But the subpoint of that satellite then must be here, right? 1, 2, 3. So there's no way around it. There's no way around this, right? They can't use a globe, even just for basic things of angles. They can't use a globe. The receiver can't find its distance, can't find the distance along the arc to the subpoint. Can't do that. Right, here we are again, back to divergent zeniths. Remember I told you about them. It can't figure out this if it's using a zenith angle. That zenith angle, remember, is off of a horizontal. Because if this is claimed to be a vertical, then the tangent they're using has to be, they're going to be thinking it's a horizontal. But that can't be a horizontal, and this one here will be a horizontal. See, these two zeniths can't be zeniths because they're not parallel to each other. They can't be verticals because they're not parallel to each other. Right? They might be claimed to be a zenith, but they can't be verticals. Right? How can they be verticals how can they be anything to each other, right? Over a curved surface? They don't mean it. This is the point. This would have to have a flat plane here, and this would have to have a flat plane here. Now, none of them, if you call them tangents, can be horizontals, right? But that makes these angles pointless because you can't figure them out. The receiver can't figure out any of this because it's going to be using a tangent at this point. Now, to show all this, and I'll show you what I'm talking about, and I'll go back to here. Here you have a tangent, this line here, right? Just going to highlight it. This line here, right? Tangent, right? Here you have its angle to the satellite, which is up here. This is the receiver, this is the satellite, this is the angle, 9.877 degrees, right? Off of this, right, to have any hope at all for this receiver finding its location on a globe, it needs this other angle, right, this 64.88 angle to this line, which goes straight to here and meets the satellite, right, zenith, or neither, I should say, that goes past its subpoint to the center of their globe. So to figure out, right, where its position is, using these divergent zeniths, right, divergent zeniths to the center of the globe, it needs to know the length of this line. But to know the length of this line, it needs to know how long this line needs to be. But it can't know how long this line here needs to be. I'm just going to highlight this slightly different, right? Change that to green as well, right? It can't know how long this green line here, actually change it to a different color because that's green. Let's go with orange. It can't know how long this orange line is, right? Because it needs to know how long the arc length is. So the receiver knows the coordinates of the subpoint, but it has an angle off of a tangent, right? That is not going to help it because the subpoint, based off of the tangent and this angle, the subpoint of the satellite is going to be out here, which I'll show in a minute. It can't know the distance along the arc of a globe to the subpoint, and it can't figure out what that length, it can't figure out this orange line or this green line because it doesn't have the arc line, right? It's going to make that like that, right? It doesn't have this serrated black line distance. It doesn't have that. It only has this angle here, 9.877. That's all it has, and the compass bearing. That's what it has. It doesn't have this other angle to this line, and even if it did, it wouldn't matter because it doesn't know what length the orange line is, because it would need to know what length the green line is. and it can't know what length the green line is if it doesn't, because it needs to know what length the orange line is, and to know what angular momentum, it needs to know what length the arc length is, and it can't know any of that because I'm just going to put on the grid a sec. This may not be perfect, but I'm going to do it anyway, right? So what the thing is that the sub, right? No, I don't want to do that, right? I'll get another loan. Well, just give me a second, right? So technically, the sub point of the satellite will be somewhere there. Let's just say something like that, right? So for the person with this, the sub point is out here. That's the actual sub point, because that's the way not the person, the receiver. The receiver only has this angle and the azimuth. That's all it has. It doesn't know the length between it and the sub point, right? No matter which one it is, it doesn't know that. But if it's going to have just this angle, then it can only use a right angle triangle to try and figure it out. Now it can't. Just going to go back a sec, right? It can't use this angle here, right? Because it doesn't have this arc length to know what this angle is. It can't do any of that. It doesn't have the information it needs to have to figure out where it is. Consequently, there is no such thing as GPS on the globe. Many years ago, I did presentations on surveying, and I pointed out that the GPS started in surveying, and I stated that as far as I was concerned, GPS did not stand for Global Positioning System. It stood for Geographic Positioning System, right? A geographical positioning system. It's been called Global Positioning System, but what they're actually doing is they're using a flat plane. Now, I'm not showing how they're actually finding their positions in this video. That's shown in my presentation on the Quantum Eraser channel, and I might make a video showing that, how they actually find their position. But the point is that they're finding their position on a flat plane, right? Because the Earth is a flat plane. They must treat the Earth as a flat plane because that's what it is, right? They're using azimuth and elevation, right? But in reality, it's mostly azimuth. But the point being is that they're back calculating it, right, for the everyday average person, and they're telling that person, oh, it's on a globe. It has nothing to do with the globe. It can't work. This is all the receiver has is this angle, 9.877. That's all it has, right? That, the azimuth, the time the signal was sent, and the coordinates of the subpoint. So now people in the chat are probably going to go to borders, but it has the time, right? And it uses Einstein. It doesn't. It has the time it was sent, but that doesn't help it find the subpoint, the distance to the subpoint. Even if it knew the length of this line, right? Even if it could calculate it using the two-way speed light calculation, right? Even if it could do that, right? Based off of the time it was sent, right? It's still, right? That's its arc, right? That is its hypotenuse. This other line here, right, that I just drew in a second ago, we'll just go forward again, right? It then is still going to be using this line and this line, which still is going to put the subpoint of the satellite out here somewhere. It can't work. Even if it did know, if it could somehow figure out based off of the two-way speed light calculation, the distance between here, it and the satellite, it still can't place the subpoint there. So the coordinates it gets and everything else will be placed up here in the sky. It can't work on a globe. GPS has nothing to do with a globe. It's purely flat plane because we live on a flat plane, right? You're being hoodwinked, you're being gaslit, and there's people out there who are supporters of the globe who are literally willing to lie, right? Why? What's the point in lying? What's the point in trying to lie to me or any other flat earther? What's the point? How is it helping you? It's not. It's not changing this, is it? It's not changing anything for you. This can't be done on a globe. It can't be done. The receiver doesn't have the information it needs to find its distance along an arc to a subpoint, and it won't have, because we don't live on a globe, and if we did, this system wouldn't work. We'd have to have a different system, right? because this on its own won't work. This can only work in any way on a flat plane. And even at that, it would be difficult to get this exact system working. But at least it would be flat for the elevation angles and the azimuth. Something you don't have. So in conclusion, this can't work on the globe. The receiver just has this angle here. It can't figure out even this angle, right? And even if it can figure out this angle and it has a 90 here, right? It can go, right, I have this angle here, this is 90, so it knows what this angle is, right? But that doesn't give it length of sides, and even if it did have this hypotenuse length, it can then only work out this adjacent and this opposite length, right? But that puts the sub point up here. No matter what way you twist or turn it, geometrically there is just no way out. So I'm sorry to the people who follow the globe. I'm sorry that this video is going to hurt you. And it is going to hurt you. You're not going to like this video. You're going to hate me. But all I'm doing is I'm just a messenger. I'm showing you, you're wrong. There's no way out. You're wrong. That's it. There's no if, buts, maybes. There's no Einstein this. There's no any of the rest of it. You're wrong. You don't understand this. And this is only one section of my presentation. I'm sorry. Doesn't work on the globe. End of story. Thanks for watching.